Hi, my name is Brendan Hanrahan. I'm currently enrolled as a graduate student at the University of Maryland in the field of materials science and engineering. My PhD thesis includes a study of friction and wear of microballs. Today, we're going to do an experiment on polymers. Well, what is a polymer? A polymer is a material comprised of long-chain molecules. This includes plastics, rubber, and even DNA. So if you were to look at these materials under a microscope, what you would see would resemble a plate of spaghetti, sans marinara. To give you an idea of how long these molecules really are, I brought along my trusty polymer chain in a can. Each of these beads represents a monomer, the single repeat unit of a polymer. So let's see how long this chain really is. And that was a short one. Now I'm going to talk about an exciting kind of polymer called a hydrogel. This superabsorbing polymer has the ability to absorb 1 molecule of water for each bead on the chain. That means it can absorb up to 500 times its own weight. Now if your household sponge could absorb this much, it would get bigger than the sink. Right here I have about 2 grams of polysodium acrylate, a type of superabsorbing polymer, and a full bottle of water. Let's see what happens. Babies and old people alike can really appreciate its superabsorbing properties. Here's a polymer I'm sure you're all familiar with. Silly putty, that's right, it's a polymer. It was invented while looking for a synthetic version of rubber during World War II. American scientist James Wright stumbled upon it while trying to react boric acid with silicone oil. After 10 years and no real use for it, it hit the toy market. Now this childhood favorite is actually a viscoelastic polymer. That means it exhibits both fluid and elastic properties. If you stretch it slowly, the chains have time to untangle and slip past each other. And it acts like honey. You put it back together. If you stretch it fast, these chains don't have time to untangle. You end up just snapping them. Like so. So now you know a little bit more about viscoelastic polymers. A common theme throughout all these experiments has been that slightly different polymers can have drastically different properties. By simply changing the chemistry of the polymer, you can make it super absorbing. Or by changing the degree of entanglement of those polymer chains, you can give it those viscoelastic properties that we saw with silly putty. Now right here I have 2 polymer balls that look the same, they feel the same, and they weigh about the same. But when I drop them on the table, you can see they're drastically different. This bouncy ball would be used for a basketball, and this energy absorbing ball could be used in the sole of a shoe. It's my job as a materials scientist to engineer these properties into materials used in everyday life. Thank you very much for joining me. I hope you had fun, learned a lot, and I hope you found your new host.